All right, welcome back, and we're going to be jumping into section 9.3 for Math 120, which gets into the geometry of triangles, congruence, similarity, and the Pythagorean theorem. Now, the one thing you'll see is that congruence is scratched out. Now, congruence is pretty interesting for some people, for some math nerds, because you're looking at when something is exactly the same as something else. But we're going to pass on that. There's a lot of cool ways that we could be looking at that stuff, but we're going to skip it. So we're going to jump right into looking at isosceles triangles. So, boom, 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 boom. And however, in delving further into isosceles triangles, we have the following properties, and there's 3 of them. So, okay, now before we can look at these statements, we're going to have a drawing. So let's draw an isosceles triangle. So they give us some guidelines here. AB is equal to CB, and if D is the midpoint of base AC, then the following properties hold. Okay, so let's draw our isosceles triangle. Now AB is equal to CB. So, well, if I put A here and B up there and C there, does that work? AB equal to BC or CB. So would these two look the same? Yeah, they look the same. So that would be a good drawing. And now if D is the midpoint of base AC, so AC is our base, it's on the bottom. So we want the midpoint. And that is D. Then the following properties hold. Base angles A and C are equal. So if the two sides are the same, then that forces these two angles to be the same. Yeah, that seems like it makes sense, right? All right, what about angles ABD? Well, we're going to need another line right down the middle. Okay, so now we have a line down the middle. So angles ABD, so that's a skinny one up here, and CBD are equal, CBD. Now, we're not talking about the non-active ingredient in marijuana, so we are talking about this angle. All right, so yeah, so these two angles up here look the same. So I'm going to put 2 dashes in each of those. Hard to see, but there's 2 dashes. And then the last thing it says is ADB and CDB are both right angles. So that's these 2 angles down here. And we can kind of see that that makes sense also. Now again, very logical looking statements, and based on the diagram, it looks logical, looks like it makes sense. But mathematicians have got to prove everything. So somebody had to prove that it was true before they could just assume it was, even though it looks like it. All right. So using the figure above, if BC is equal to 12 inches and the perimeter of ABC is 30 inches, what is the length of AC? Okay, so BC, so over here is 12 inches. What is the length of AC? Well, what can you tell me? And you also know that the whole perimeter is 30. So hopefully you're saying, well, if this is 12, then that forces this one to be 12 too, right? And you would be correct. So we got 2 12s and then we got an unknown. So let's call it X. Our 2 12s should be equal to 30, right? All 3 sides. Perimeter is all around the outside. So that's going to be equal to 30. So if we do X plus 24 equals 30 and subtract the 24, we can quickly see that X equals 6. So that means that AC is equal to 6 inches. All right, not much to that stuff, right? Okay, let's get to something more interesting. Similar triangles. So if two triangles are similar, then they are exactly the same shape, but just not the same size. So if I have one triangle that looks like this, and it's A, B, C, and I got one that's just a little bit bigger, and that's D, E, F. You can kind of see they're, well, not perfect, obviously, but they're roughly the same shape, but just one's a little bit bigger than the other one. So now if I'm claiming that those are similar, that means some things have to be in order. So if ABCD is similar to triangle DEF, then we can establish some correspondences. Okay, so angle A would correspond to angle D. So we can kind of see that those two are supposed to be looking similar. You know, we're going to get more specific terms in a second, but just bear with me. So those two are related. A or B is related to E, and C is related to F. Okay. Likewise, we can do the same sort of analogy with the sides. So AB is related to DE, BC is related to EF, and then AC is related to DF. Okay. So when similar triangles happen, we can set up correspondences between the angles and the sides. But what exactly does that mean? We're going to see in a minute. So let's see if we can set up some correspondences with this one. What correspondences can we identify in the following figure? So what angle would correspond to angle A in the other triangle? Would it be D? It turns out it's going to be E. E is going to be corresponding to A. And then likewise, we can kind of see that B and D are going to correspond. And then even on the inside here, those ones correspond. So there are some correspondences going on, but what's going to happen even more so is that we're going to have some equalities. So you can kind of see what I did there. Angle A is going to be equal to angle E. They have a single dash in there. B and D are going to be equal, and then these two angles here are equal. Why are these two equal? What kind of angles are those? Remember back from 9.1? Those ones are vertical. So those are vertical angles. So they have to be equal to each other. And these ones are going to be equal because, I didn't say it, but these two lines here look awfully peculiar, don't they? Yeah, because they're parallel. So those are parallel lines. So we're going to have some of those angles, those obtuse and acute angles that were equal. That's happening here. These ones are equal because they're both acute. These ones are equal because they're both acute. We have one transversal going here, and we have another transversal going there. So that's why we get those angles to be equal to each other. And we could also set up relationships with the sides, but I'm going to skip that. But the big question we're going to want to know is, how do we find those missing sides? Because we can't say that they're equal. We can definitely see that this one's going to have to be smaller than this one, and so on and so on. So how do we get those, how do we find those missing sides? Well, it turns out we have two conclusions. The first one we just said, that the corresponding angles must be equal, but the sides are going to be proportional. So we can set up proportions to find those missing sides. So let's take a look at a couple problems. And how long are we in? 9 minutes-ish? All right. So if we got our smaller triangle here with sides 6 and 4 and our bigger one here with sides 9 and x, how could we set up a proportion to find that missing x? And there's lots of ways to set it up correctly. So you might just pick one that works. But if we wanted to relate corresponding sides, we would want to say this side corresponds to this side. So we could use that as half of our proportion. So what should the other side look like? X over 4 or 4 over x? If you started with this one first and then went to this one, you're going to start back with this one and then go back to the second one. So it would be 4 over x. And now it's just a quick cross multiply and divide. So you got 6 times x equals 9 times 4. 6x equals 36. So x equals 6. Very, very quick. Now, to make it a little trickier, we could have something like this. So now it's a little bit trickier to see how that proportion should get set up. Now, what do you think about this setup? I'm going to say, okay, I'm going to go 50 over 100 equals x over 120. Do you think that one is right? Will that work? I mean, we're kind of relating stuff in one triangle and we're kind of relating stuff in the other triangle, but it's not right. And the reason why it's not right is because we're not relating sides to sides. So, and the way we can see that is if we pull them apart. So if we got our smaller triangle and we got our bigger one. Now, the 120 is not the length of the entire side, it's just a small piece of it. We have to add these two pieces together, and then that is the whole side across the bottom. So this is 220, and this was not 500, this was 50. Make sure you don't put too many zeros in there. Okay, so now if we wanted to set up our proportion, what should it look like? It's actually very similar to this one, except the only difference is instead of 120, we should have wrote 220. So now you're probably saying, well, wait a minute, we're not relating sides to sides. Shouldn't we have 100 over 220 and 50 over x? That is definitely going to work as well. But you can just put one side over another side in the same diagram, in the same picture. So that's what I did here. 50 over 100 equals x over 220. And if I had done that over here, I could have said 6 over 4 equals 9 over x. And it will give me the same cross products. And you can tell by looking at it. 6 times x, 4 times 9. So you still get the same cross product, even though it's a little bit, I think it's a little bit nicer way to set it up because you just almost put a fraction bar right in there. So that's kind of what we're doing here. We're putting a fraction bar there and a fraction bar there, and you're good to go. So cross multiply. 50 times 220 is 11,000. Divide by 100, and you get 110. So 110 is your value of x there. All right, so just be a little bit careful with those embedded diagrams because they're trying to trick you. So, okay, let's do one more, and then we'll pick up the rest in the next video. A tree casts a shadow 45 meters long. At the same time, the shadow cast by a vertical 2-meter stick is 3 meters long. Find the height of the tree. All right, well, get out your drawing skills that you've been hiding and see what you can get. A tree. All right, so let's get a happy little tree here. If you're young, you don't know that reference. If you're not, you do. So there's our happy little tree, and it's got a shadow on the ground that's 45 meters long. So, all right, but at the same time, a vertical pole is got a, that's 2 meters, is got a 3-meter shadow. So they want to know how tall the tree is. Well, once you get your diagram, now you can quickly see what's your proportion going to be. So just like we did up above, we can just put a little fraction bar right in here. So x over 45 and 2 over 3. It's that quick. So cross multiply. And then divide. So the height of your tree should be, don't forget your units, 30 meters. So, okay, so let's stop there and then we'll pick up the rest very shortly. See you soon.